Hello everyone, today is day 3 of 6.2 where we're learning how to perform operations with rational expressions. Days 1 and 2 we learned how to add and subtract. Today on day 3 we are going to learn how to multiply and divide. Rational expressions. And if you're keeping track of what day this is day 3 of the section. A couple notes to write before we actually get into practicing. We're going to look at one operation at a time. So if we're multiplying, we want to see if anything can be canceled or factored first. So see if anything can be canceled or factored first, then multiply straight across. Multiply straight across. For dividing, our strategy will be to turn it into multiplication. So turn into multiplication by multiplying by the reciprocal of the second fraction. And what's nice about that is once it's turned into multiplication, we're right back to where we first started, which is seeing if anything cancels or factors, and then multiplying straight across. The best way to learn this is to practice, so let's get right into our first example. Number 1, 8y squared divided by 7 times 35x divided by 20y. So this is multiplication. Let's read what we wrote. See if anything can be canceled or factored first, then multiply straight across. Well, I see that I have all monomial terms here. Monomial, 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 monomials all over the place. So no factoring can take place. Let's straight up see if something can cancel. 8 and 7, nothing can happen there. But I see 7 and 35. I know 7 goes into itself once and into 35 5 times. What else can we do? Well, I see 8 and 20. I know that 4 divides into 8 twice and into 20 5 times. But look at that. These 5s, 5 and 5 will cancel. Now let's look at our variables. There are no x's in the denominator, so x is going to stay in the numerator. But notice I have a y squared in the numerator and y in the denominator. This y will cancel with one of these, leaving this one. Sometimes when a lot is getting crossed out and I don't want to lose track of something, I'll circle it to draw my eye to it. we've done all we can with canceling, and so now we're going to multiply straight across, because with multiplying fractions, that's what we do. So for example, way back when, if I had asked you like 2/3 times 1/5, 2 times 1 is 2, 3 times 5 is 15. So just like you would multiply fractions way back when, same property applies. Just multiply straight across. So when I look at to see what I have, 2y x divided by, and I look in the denominator, all that's left is 1. Dividing by 1 doesn't change anything, so my answer is 2xy or 2yx, however you choose to write it. Number 2, 4y minus 4x squared divided by x squared plus 2x minus 3 times x squared plus x minus 6 divided by 4x. This is multiplication. So again, let's go read our strategy. When we are multiplying, see if anything can be canceled or factored first. Well, I see that I have a binomial, so at the most I can do here is a GCF. But now in this example, I have 2 trinomials. Let's see if we can factor those. So we're going to go a piece at a time. What I mean by that is I'm literally going to see this as my first piece, second, third, fourth. Look at it a piece at a time. So looking at this first piece, 4y minus 4x squared, I ask myself, what can I factor out? X's and y's, those are not common, but this 4 is, so I can factor out a 4, leaving y minus x squared behind, divided by, a is 1. I need factors of -3 that add to 2, so that'll be 1 and 3, where 1 is negative. So I get x minus 1 times x plus 3. So I just finished looking at my second piece, times. Now I'm looking at this piece, x squared plus x minus 6. A is 1. I'm looking for factors of -6 that add to 1. So I'm thinking 2 and 3, where 2 is negative. So I'm going to get x minus 2, x plus 3, all divided by 4x. Now that we have factored, let's see if anything can get canceled out. What are you thinking? Well, the first thing I see is this 4 right here divided by this 4. Remember, I technically could write this as one giant fraction with no multiplication dot in the middle. All of this is getting multiplied in the top. All of this is getting multiplied in the bottom, which means everything here is getting divided by what's down here. So I read this as 4 divided by 4 is 1. So my 4's cancel out. X plus 3 cancels with x plus 3. Nothing else is going to cancel, so now we're going to multiply straight across. So I have y minus x squared times x minus 2 divided by x times x minus 1. If I had space, I would go one more step and I would write it out so that my denominator is all the way multiplied out. No, I'll just put it right here. So just like addition and subtraction, we want to maintain that habit. The numerator can be in factored form, no problem, but let's always make sure our denominator is multiplied out when we're done. So distributing x back in, I would have x squared minus x. And now we're done. Number 3, 5x divided by 3x minus 12 divided by x squared minus 2x divided by x squared minus 6x plus 8. We are now working with division, so let's go read our strategy for division. When we are dividing, we are going to turn it into multiplication by multiplying by the reciprocal of the second fraction. So we keep this first fraction just as it is, 5x divided by 3x minus 12. This turns into multiplication by multiplying by the reciprocal of this fraction. So we just turned division into multiplication by this step right here. Multiplied by reciprocal of the second fraction. A short way of remembering it that some people like, it's called keep, change, flip. So what keep, change, flip means is keep the first fraction, change division to multiplication, and flip the second fraction. Keep, change, flip. So you can either remember it that way, keep, change, flip, or multiply by the reciprocal of the second fraction, whichever works for you. Now that we're back into multiplication, we're right back to what we did in numbers 1 and 2. We're going to see if anything can factor. So right now on your own, I want you to look at each of these pieces. Remember, you've got 4 parts to look at. 1, 2, 3, 4. And decide, do you have a GCF that can factor out? Is it a trinomial where you can factor? $5x I can't do anything with, so that stays. 3x minus 12, I have a GCF of 3, which leaves x minus 4 behind. A is 1. Factors of 8 that add to negative 6 would be x minus 4, x minus 2, all divided by. Here, with x squared minus 2x, my GCF is x, leaving x minus 2 behind. Now that we factored, let's see what cancels. What do you see? I see this x and this x cancel. X minus 4 cancels with x minus 4. X minus 2 cancels with x minus 2. And we ask ourselves, what's left? Well, no terms are left in the numerator, but a numerator can't just be nothing. We leave 1 as a placeholder. And in the denominator, 3 is left. So this answer is 1/3. I take that back. 5 is left. As I said 1, I saw 5. Apologies. 5. 5/3 is my answer. So my little verbal mistake right there is a great opportunity to talk about being careful with what you cross out. When I looked real quick, it kind of almost looked to my eye like I had also crossed out the 5, which is why at first thought I saw, oh, everything canceled. But then I was like, wait, no, 5 didn't cancel with anything. So be careful. When you're canceling, don't let your cross out marks travel too far, because then it may look like you crossed out something you didn't mean to. Number 4. (6x squared) plus 7x minus 3 divided by 6x divided by 2x squared plus 3x. We have division. The very first thing we're going to do before anything else is turn this into multiplication. Keep the first fraction the same. And now you finish. You finish turning this into multiplication, and we'll see if we match what we write. So look at what we just did in number 3 and decide what's going to come next. So we kept the first fraction the same, changing this to multiplication, and multiplying by the reciprocal of the second fraction. So just like with adding and subtracting, when something doesn't look like a fraction, make it 1. So technically, this factor, 2x squared plus 3x, is being divided by 1. So if it helps to draw in those invisible ones, do so. Now that we have multiplication, we can start looking for GCF and what can factor. So see if you can finish this one by yourself. Let's factor, look for GCF, simplify, pause here, and then we'll compare answers. My first thought when I look at 6x squared plus 7x minus 3 is maybe there's a GCF, but then I see this 7 and I know that's not the case. So I'm looking for, oops, let me get back to blue, this kind of situation where I have to decide, am I going to work with 6x and x or 3x and 2x? I think I'll start with 3x and 2x. And then I'm going to look to see guess and check with factors of 3. Inner, outer equals middle. Well, I know if I put 3 right here, that'll get me 9. That's promising. So then I put 1 right there. I'm trying to get to a negative 3. And I think if this is negative and this is positive, I'll be in good shape. Let's check. Inner gets me negative 2x. And the outer gets me a positive 9x. Add that together, and it's the 7x I need. This is still being divided by 6x times 1 divided by. Here, I have a GCF situation. I can factor out x, and that leaves behind 2x plus 3. So let's see what can cancel. What do you see? I see 2x plus 3 will cancel with 2x plus 3. And nothing else. These x's are both in the denominator. So these do not divide to equal 1. So you can't cross out the x's. So that's as far as we can go. Let's see what's left. 3x minus 1 times 1 is just 3x minus 1 divided by 6x times x, 6x squared. And just a side note, as tempting as it may be to say that this 3 and this 6 becomes 1/2, do not do that. That's an example of canceling terms, not factors. Number 5. If you're towards the bottom of your page, make sure you have not a ton of space, but if like you're in the bottom line of the page, start a new page. Number 5 says 2 divided by x plus 2 divided by 1 divided by x plus 2 plus 2 divided by x. I can just imagine the faces we're making at this problem, but no worries. I promise we can do this together. Just going to center this a little bit. So the first strategy is actually to get this, do this addition first. So off to the side, if you wanted to work on it and then come back, that's fine. So I'm going to do 1 divided by x plus 2 plus 2x. And we're experts at addition. The question is, what is my LCD, my least common denominator? Well, I've got x and I've got x plus 2. So the common denominator will be x times x plus 2. To make that happen, we multiply this fraction by x divided by x, and this one by x plus 2 divided by x plus 2. When we do that, we're going to get x divided by x plus 2 plus, remember this 2 gets distributed to everything, so 2x plus 4 divided by x plus 2. I now have those common denominators we've been always looking for with addition or subtraction. So now I can straight up add the top. And it's nice because this was addition, I don't have to worry about distributing any negatives, just straight up combine like terms. So x plus 2x is 3x, and then plus 4 is along for the ride, x plus 2. So you can literally kind of like put this in a box or a bubble. It's a little side work we did. We're now going to bring this into that problem and rewrite 2x plus 2 divided by 3x plus 4 divided by x plus 2. Now, as crazy as this notation looks, I want to show you something. Listen to what I said out loud. So, same as 2 divided by x plus 2 divided by, in other words, divided by 3x plus 4 divided by x plus 2. These notations are the exact same. Remember from way back when, this division bar and this division sign mean the same thing. So if I showed you this, we're going to do exactly what we just did in number 4. Keep the first fraction, change division to multiplication, and multiply by the reciprocal of the second fraction, or keep, change, flip. And let me ask you what cancels. Well, I see this x plus 2 is a factor that will cancel with this x plus 2. I don't see anything else that cancels, so now we're ready to multiply straight across. So I have 2x divided by 3x plus 4, and that's as far as I can go. So really what made this question a little more involved is you had some addition work to do on the inside as part of a little side work. The next part of it was realizing that this division bar is the same as using this division sign, where you're going to keep the first fraction, change division to be multiplication, and then the reciprocal of the second. And we're right back to a question we're more familiar with how it's written. But this notation is expect this just as much as this, and be comfortable. Make yourself a little note that this is the same. It'll come with practice. We'll have plenty of chances to practice. We have 2 more examples to do to round out the notes. Number 6. (2x to the third) minus 12x squared divided by 2x squared minus 13x minus 24 divided by 4x to the fourth plus 28x to the third times 2x squared plus 11x plus 12, all divided by x minus 6. This is a rock star question. Gotta love it. So, first strategy, let's factor. What can I factor out of this? What do you think? I see 2x to the third minus 12x squared. At a minimum, x squared, and then 2 and 12, GCF is 2. So the complete GCF is 2x squared. What's left behind? X minus 6. Believe it or not, we're going to be done in 3 steps. So as crazy as this looks, watch how fast we get this done. A is not 1. There is no GCF. So we're going to be doing 2x and x. Let's guess and check factors of 24. What do you think is going to work? Pause and you factor it, and then we'll compare. This ends up factoring to be 2x plus 3 and x minus 8. If you struggle with that, pause for a second and you check inner, outer equals middle. In the same step that we're factoring, we are going to change this division to be multiplication. So we're keeping the first fraction, changing division to be multiplication, and multiplying by the reciprocal, flipping that fraction. At the same time, I can look for a GCF. I know I can factor out 4x to the third, and you tell me what's left. I've got x plus 7 left. So that was keep, change, flip. And we performed that while we're taking care of our factoring situation as well. 2x squared plus 11x plus 12, no GCF. So again, A is not 1. Go ahead and pause, you factor, guess and check with factors of 12 to get 11. Works out to be 2x plus 3, x plus 4, all divided by x minus 6. And now it's so much fun because all we need to do is see what cancels. So I'm going to have you please pause it right here and you see how much that you can find that cancels, and then we'll compare. So maybe it's because the last thing I wrote was x minus 6, but the first thing I noticed is that this x minus 6 in the bottom will cancel with this x minus 6. Then I see this 2x plus 3 cancels with this 2x plus 3. X minus 8, nope. X plus 7, no x plus 7s, x plus 4. Okay, so all these other binomials are going to stay. But what can we do with this 2x squared and 4x to the third? Well, 2 goes into itself once, 4 twice. 2/4 becomes 1/2. These two x's cancel with 2 of them, leaving 1 behind. Now that we've canceled everything we can, let's multiply straight across. Checking here, this is now just 1, 1. So x plus 4 is left behind, divided by 2 out front. And anything else? Let's see. X minus 8 and x plus 7. And we're done, as far as we can go. So notice, really, 1, 2 steps in terms of factoring. Third step was seeing what cancels, and then multiplying straight across. One more question to round out today's notes, number 7. It's going to be our real world question. The length of a rectangle is 9 divided by y plus 4 meters, while its width you gotta be kidding. Alright guys, I'm going to stop the video here just because it looks like Smartboard's having a problem and I don't want to lose the first part of the video. But I will post a picture of the real world solution, okay? Have a great night. The homework tonight is the dividing and multiplying worksheet that says day 3 at the top, day 3, multiplying and dividing. Again, number 7 you'll get from a picture that I will post to Google Classroom and to Remind. Those of you who picked up the Type 3 early, feel free to get started and work on it. We will officially be working on it tomorrow in class after we check answers for multiplying and dividing. Have a good night.